if you do A-level PE and you're struggling with the Krebs cycle, listen up to this. So you'd always want to start by saying, where does it happen? So let's say this is a mitochondria. A mitochondria has two membranes, and the inner membrane is really folded, and those folds are called the cristae, but we'll ignore that for now because that's where the electron transport chain happens. But the Krebs cycle happens in the matrix of the mitochondria, and I always remember M for middle, M for matrix, and you'd have to say the matrix of the mitochondria to get the mark. Then you'd want to explain what's going on. So acetyl-CoA from the first stage, aerobic glycolysis, enters the matrix of the mitochondria and it binds with oxaloacetate. So acetyl-CoA is 2 carbons long. It binds with oxaloacetate, which is 4 carbons long, and that creates this molecule here called citric acid, which is 6 carbons long. Not that you need to know the carbons, just so you can visualize what's happening now. And that citric acid is then oxidized as it goes around the Krebs cycle, and that just means that it's broken down. So it starts off as this 6 carbon molecule, it gets broken down into a 5 carbon molecule, and eventually it gets broken down back into oxaloacetate, and that's why it's called a cycle. Now, because citric acid is being oxidized, it's losing carbon, and this is where oxygen comes along and it binds with that carbon to form CO2. So CO2 is one of the 3 products of the oxidation of citric acid. As it loses carbons, you might remember from GCSE chemistry that there would be hydrogen surrounding a carbon atom. So not only is it losing carbon, but it's also losing hydrogen. So that's the second product. And then finally, there's enough energy release to resynthesize 2 ATP. So you would want to say that in the Krebs cycle, acetyl-CoA binds with oxaloacetate to form citric acid. The citric acid is then oxidized, which produces CO2, hydrogen, and 2 ATP, and it all happens in the matrix of the mitochondria. And if you wanted to, you could finish by saying that hydrogen is then transported to the electron transport chain via proteins called NAD and FAD.